Okay, we want to draw the level curves of a pathological surface. And really this should read something like, here's motivation for needing a harder core second derivative test, right? So the idea is I want to create something that's concave up in both the x and y directions, right? So I'm just going to make some points that are indicating heights, and then we'll draw level curves to connect them. Okay, see this?
Yeah.
So I want this thing to go up in this direction. So maybe let me just make a parabola. You guys buying into that?
Sure.
Right, so at 1 it'll be height 1, at 2 it'll be height 4, at -1 it should be height 1, at -2 it should be height 4, 9, and 16, right? And then I want the same thing in the y direction. So the object I'm making should be concave up in both x and y. So 1, 4, 9, 16 going up, and 1, 4, 9, 16 going down. But then I want it to be concave down, right? So these are concave up. Right now I've got a really nice potential minimum here, right? Now I'd like to say, but I tricked you, that's a saddle. So I'd like for there to be along this direction, right? Like maybe here, I could go -1. Here we could go -4. Here we could go -9, -16. Right, so now I've got a parabola pointed down along the diagonal. And similarly the other way, right? So -1, -4.
It's almost as if a crown.
Yeah, it's kind of a funny folded star-shaped thing. Let's see, and in the other direction I do the same. And it should be clear, right, that I can't connect the level curve that's on this guy is not going to connect to that one, right? Okay, so can you guys envision what the rest of the level curves are going to look like?
Yeah.
So right now the kind of blacks are positive and the blues are negative, right? And I just need this, I need some shape.
Like sort of two hyperbolas, sort of?
Yeah, so these just need to not hit each other, right? That's really the only rule. So there's your one level curves, right? So it's coming up in the x and y directions. And then I need down in these directions.
Then you get funny stuff in the middle.
Yeah, and in the middle, what's happening? Well, it's transitioning, right?
Like
So there's a 0 level curve in between there, right?
Yeah, it's like an 8-way X.
Yeah, and this is getting steep in there, and steep along this, right? Yeah, so this is like a lot of ways an X, right? You guys see that? Okay, so then I've got these kind of deeper level curves. I'm just going to ditch these points for clarity. So those are falling down deeper, right? So do you guys all buy that this could be a smooth surface?
It can be continuous.
Yeah, and even better than continuous, probably even differentiable everywhere.
Yeah.
Isn't it just like a flower?
Yeah. Yeah, it's a flower, it's a Chinese fan. Perfect.
One of them thingies.
It won't fold all the way open.
Oh, those fans.
So this won't fold quite all the way open, right? But if we threw another one on here, and this one has way more folds than we're looking at here, right?
Yeah. I have one of those.
But that's really the idea, right? We've got a bunch
You
of
would have
peaks coming in 4 directions, and a bunch of valleys also coming in 4 directions. Okay, see that? Okay, so what's the point of this thing?
The standard second derivative tests won't work.
Yeah, so the second derivative test I'd like to apply is something like, well, if the xx derivative's positive and the yy derivative's positive, then it's probably a minimum, right? Like, it's concave up in two directions. Maybe? But this thing's concave up in two directions, right? And concave down in the other two, so...
Is it the same thing we were talking about, making like the gradient of a helicoil that we were doing on what, Thursday? Gradients of a helicoil.
No, this will be even easier, because I don't have problems here with this thing being a function. Right, if I think about a vertical line test, it only has one height, right, for a given point. So here I have a nice convenient function, right? The gradient's everywhere defined. It's 0, right, here at the middle, but it's because it's flat, right? In all the, like, every which way from there, it's flat. So I'll see that. And my 0 level curve looks like this, right? Oops. You see that?
There's
So when
the
your
eight
0
ways.
level curve's messy, right? You should be worried. Unfortunately, it doesn't have to be a 0 level curve, so you can't go check this all the time, right? So the thing you need is a slightly more robust second derivative test. Really, if we incorporated the fxy and the fyx derivatives, you guys see those here?
Even that wouldn't.
Yeah, that won't be quite enough. But if we incorporate them in the right way, we'll get an answer out of this most of the time, I think. You guys remember the second derivative test doesn't work all the time, even in Calc 1. Right? Sometimes it's inconclusive. Yeah. Here we're going to run up into that same thing. But we can get at least partway there as long as we have the x, y, and yx derivatives also included.